Hello folks, this is Pierre-André Mathieu and I'm here today with a tutorial on how to fix the enemy step. Now, I'm going to play my project here. As you can see here, I can jump onto the enemy but when I'm locking on, I get stuck in an infinite air jump loop, and I'm sure many of you are suffering with this issue the same way I am suffering. But luckily, there is a fix to it, and I'm going to show you how to do that. But before I show you how I fix the enemy step, let me give you an update on how I made a few changes within the dynamic action capability system. Okay, this is my dynamic action capability system. What you're seeing here is an evolution of the original one, in which I showed you a year ago. What I did here is I evolved it into a much granular explicit state machine. I did it by flattening out the logic into a sequence of local assignments. What I did here is making the evaluation highly readable and easier to debug step by step. And as you see here, I added the taunt to the core of my combat capabilities. For a stylish character action game, this is a massive mechanical addiction, perfect for letting the players aggressively build up style rankings or provoke an enemy AI to overcommitting. On my last video involving dynamic action capability system, I'm not using a bulky set members in struct node. I use simple Boolean operations. Now I'm routing the input parameters through a linear chain of individual set nodes to assign local variables. This right here shows the initial dynamic action capability system node passing execution to individual sets for jump and move. The main chain is basically execution cleanly tracks through melee attack, range attack, and dodge. In addition to the block and taunt. And as I conclude the lane here, I have a burst and enemy step. I localize the variables inside the function itself. That way I don't have to add like 7 variables. Those variables exist only within the function itself. Now, as you can see here, once I completed the whole sequence here, running through all the independent local variables, right here is where I hit a big final assignment. What I did here is I reassemble the action structure here. This variable here is sorry, wrong one. This is the one. This variable here is a structure variable based on this one here, in which I created. The individual results, which are the local Boolean variables I have here, they're piped into a single action structure set node to populate the member properties of the final action structure. This, in turn, neatly results the sequence right before hitting the return node, ensuring the final structural payload is entirely updated with crisp, isolated data points. So, by flattening the system out in this form, I made it very simple to insert unique branches or modifiers for a single capability without risking regression bugs in the others. And just to give it a little test run, I'm going to add a breaking point. Now, when I press the jump button, it all comes back right here. See? It's the same results as I displayed in the previous tutorial involving dynamic action capability system. The results is exactly the same because logically I'm passing the exact same Boolean variables into my state checks. The real magic here of this update isn't about altering the player's immediate experience, rather entirely about making things simple as I can for a much easier behind the scenes. So by restructuring the system in this form, I basically changed my workflow in a few areas, large areas, so to speak. One, if my character suddenly can't move during a playtest, I don't have the ability to decipher a complex multi-input Boolean math tree. I can place a single breakpoint right on the local set node, which is the one I have here, and instantly see what's actually failing. Now that every single capability has its own dedicated step-in executed chain, I have a perfect hook to inject unique style game specific logic later. For instance, if I want to allow a, say, taunt at any time except when the player is actively caught in a hit stun animation loop, I can just cleanly break the execution line right before the set taunt node. Branch off to check my damage state and set it accordingly without risking a bug spilling all over into my jump or melee logic. Every pin on the sequence fires sequentially from top to the bottom, forcing a predictable frame-ordered execution. These pin nodes here, they track cleanly through what appears to be a ladder of distinct conditional lines. Originally, I didn't have a return value, but now with this, using these to feed back into these nodes right here from the localized state lines as seen within the dynamic action capability system. I structure my setter like this to basically turn it into a simple data right into an active state interceptor. Whatever system calls character actions doesn't just push the data blindly anymore, because the function now outputs a return value per sequence line. The calling line can instantly receive confirmation of whatever that specific capability successfully toggled or got blocked by another overriding priority. If a specific condition falls inside the lane for then 3, it can hit its What I'm saying is it can hit its precise return node momentarily, halting that sub-branch without ever breaking or delaying the rest of the sequence chain. What you're seeing right here is the very textbook implementation of using an explicit return payload to build a highly responsive input buffer or combo windows management system directly into my animation states. Now, let's take a closer look. This logic is nested inside a player ability custom animation notify class within the overwritten receive notify function. It explicitly grabs the player reference using get player interface message plugin right here. It immediately calls my newly structured set character and actions function, mapping individual instance parameters straight into the character's capability channels. Those channels right here. Now, the real breakthrough here happens immediately after the setter executes. The red return value boolean pin coming out set character actions is piped directly into the condition of a branch node. What this does here is turns my setter into a conditional gatekeeper for the animation layer. if the character state machine confirms that an action capability was successfully permitted or overwritten, execution flows straight into the release buffer function pin, which is the one I created right here. If the state check fails, the execution bypasses the input buffer, releases entirely, steering straight to the final function return window. Now, why is this architecture scales perfect for high octane action? In games like Devil May Cry or Bayonetta, managing the exact frame windows where input buffering is accepted versus when a player is locked in, heavy recovery or hit stun is everything. By running my animated files through this pattern, I built a completely automated safety value. An animation can violently demand a buffer release on a specific frame, but if a master character logic flags that the action wasn't legally allowed to switch over at that exact moment, the said character action's return no silently falsifies, stops the buffer from triggering, preventing any nasty input dropping or state desync glitches. Now, to reinforce my point, I'm going to put this to the test. See that? It works. Now, let's dive into the real issue at hand. How to fix the enemy step. Okay. I have this here. As I said in the beginning of this video, I'm suffering an infinite air jump loop, and I don't want that. So, what I'm going to do here is I'm going to remove this from the event tick, because this here is what's causing the infinite air jump loop. And just to reinforce my point, I'm gonna add a breaking point. Okay, not what I expected, but sure. Either way, I'm removing this. I'm going to remove that too. Now, I'm gonna go inside player jump. Create a variable out of this. Get rid of it. Then reconnect it. I'll delete that. Put it back. No problem. Now, onto the issue at hand here. Okay, so what I'm going to do here is I'm going to drag a node from Ven2 bring out a branch, then from the condition I'll have to make sure that it's equal to an integer. If you're wondering why I have this, well, go to editor preference, and as you see here, type in enable promotion. As you can see here, I uncheck enable type promotion to false because, well, promoting those empty inputs here is gonna slow my workflow down. Don't get the wrong idea. It has its fair share of advantages, but sometimes well, let's just say I prefer to do things the old-fashioned way, as I would in Unreal Engine 4. It's a matter of personal preference. But enough of that. Now that I have this, I'm going to extract the ink denominator and search for state parameter. I have to ensure that the state parameter is equal to 1, which is the jump, of course. Then what I'm going to do is, if the state parameter is equal to 1, then all I need is a capsule trace. By channel. I'm going to do it for 1 frame just for testing purposes. Actually, I'll use a sphere trace. Since it's a bit simpler, I'll make an array and I'll ignore the player character because, well, I'm jump stepping an enemy, not the player. I'm gonna bring out the mesh. I'm going to get socket location, duplicate that, I'm using those to determine where the foot starts and where the foot ends in order for me to detect whether I'm using the player's feet to determine whether I can perform an enemy step on the character. Keeping that in mind, I'm going to type in foot R endpoint. I'm gonna type in the ball R because that's exactly where the end of the foot is. Of course, I'll do it in 1 frame. I'm gonna set the radius here to 45. Now, I'm gonna give it a little test run here. As you can see here, as I'm jumping, this is my tracer here. Whenever I jump, I use that tracer to detect an enemy for me to jump off. So yeah, but I'm not going to enemy step with just 1 foot alone. Of course, I could use the route to save myself the trouble, but since the player character is using both feet, I'm gonna have to be a little more realistic, keeping that in mind. Well, with what I said about the player needing 2 feet in order to perform an enemy step. So, I'll need a sequencer. I'll duplicate it. I'm gonna need to change it from from right to left. Now, let's see. Yep. What I need is 2 feet in order for my character to be able to perform an enemy step. From here, I'll need a branch. Then on hit, I need a break hit result. I'm gonna have to extract a known from hit actor, and I'll need actor has tag. From the return value, I'll use set enemy overlapping. The tag I'm going to use here is enemy AI blueprint. I'm going to double click on this. my enemy AI is already highlighted, so I'm going to type a tag, and the tag I'm looking for is the actor. So I'll add this. Yeah, paste. Just in case, I'll add a branch here. Need a print string. Let's see. Uh-oh. Let's try again. Yeah. Enemies detected. Strange. The character shouldn't be doing something like this. I think I know why. Yeah. By the way, in case if you're confused as to how I got this, I'm going to double click it. Is character in the air is a macro that I created in my character macro library, which I have here. And this one stems from get character blueprint. what I did here is I created this as an alternative to casting, and believe me, casting causes is the hardware on the computer to slow down, you know, loading a bunch of stuff that's unnecessarily. By the way, stylish action blueprint function library. I created it with the use of the blueprint library. All I'm going to do is just click it like this, and I can rename it however I want. And you can add a bunch of stuff here too as well. Anyway, I'm going to, okay, if this is false, then I need to be able to stop the player from overlapping the enemy. Let's see. There. I want to make sure that this is only detectable when an enemy is valid. So I'll bring out a branch again. Now, let's see if I'm right about this. Yep, I was right. Right on the money. Now that I have one for the right foot, I'm going to do the same thing for the left foot. I just need to copy and paste so that I don't need to waste any further time. Okay, I have that too. Now, let's put it to the test. There we go. This method right here makes far more sense than what I originally have. Because it wouldn't impact the lock-on system as much. Only when I'm close to the enemy. There we go. This right here is the closest thing that what I'm saying here is my method here is the closest thing I ever have to an enemy step like the one you see in Devil May Cry, in the Devil May Cry series. And it fits perfectly. And that'll do for this tutorial. Now, if you enjoyed this video, please like and subscribe to my channel for future tutorials regarding stylish action video game. And do keep in mind that what you take and learn from me is yours to do with as you see fit. Peace out, and I will see you guys on the next video.